I just discovered this. If I turn the light on, it shoots back like a fireball. Okay, this is part 3 of our tutorial on how to make a game with no experience. So far, in our last 2 episodes, we have got to this stage, where we have a little guy moving around in response to our keys, and much bigger splash screen now. Guy moving in response to our keys, and then we click to fire and spray bullets everywhere. The reason there's a new splash screen is that I've just switched to, I'm actually using the latest free version of GameMaker now. Previously I was using the full version and just assuming that you would be able to follow, and I think that's been the case, but I figured I should actually switch to the version we're really using. So our code so far is just this bit handles the movement, that's why we've put a movement header there, and this bit makes the player point towards the cursor, and this bit creates bullets when we hold the left mouse button. Now that we actually understand how that works, I'm going to delete some of the empty lines here. Those don't make any difference. And once you know what you're doing, the more you understand your code, the less white space you need, I find. If it's really complicated, I need to be like, okay, that bit is that, and then I need a lot of mental room to think about this. But now this is all easy, we all totally understand this. Some of you have been posting your progress so far on Twitter, which is awesome. If you do that, please loop me in at the end of your tweet. I am at pentadact on Twitter there. So I can see it, because some of them have been great. Someone's making a game called Point Gun. And what I've noticed from that is that some of you have taken the smart extra step of making bullets directional. Like when I made a bullet, it's just this amorphous blob, but some of you are making like more bullet-shaped bullets, and what you will have found when you fire is that they're all facing right, no matter what angle you shoot them at. So let's actually do that ourselves, because that was a good idea. Let's pretend our bullet is kind of like just a bit wedge-shaped. And maybe I'll make it slightly brighter towards the tip, just in case it's at all ambiguous. Probably won't be. That's the worst bullet sprite in the universe. So all we're doing now is just making sure that we can tell which way the bullet is facing, and by default sprites in GameMaker are facing right. That's how you draw them, is facing right. And so if we want to make a bullet face the direction we're shooting it in, we know how to change the property of the bullet, right? We would type my bullet and then a dot, and we know what the variable for which way we're facing is. It's image angle. We use it up here. I say pointing at my screen as if that's going to make any sense. It's up here. So my bullet.image angle, and then we also know what angle we want it to be. It's the same one we're facing, same one we're heading, which is the player's image angle. We could also just put direction there if we wanted. But it is very important to remember, if I was to think, oh, this is the same as our direction, so let's write direction, you've got to remember that if you just say direction on its own, we're talking about the player's direction, because this is running on the player. We would have to tell it we mean my bullet dot direction. Whereas the image angle, we actually do mean the player's image angle. We want to copy the player's image angle to the bullet, because at the time you're firing it, you're facing the direction you want the bullet to be facing. Let's just quickly check that works, and then we're going to move on to enemies will be today's thing. We're going to add enemies, it's going to be great. Last time we made it a video game because you can shoot bullets, and this time we'll make it, I don't know, interactive in some meaningful way. Okay, so you can't really tell which way they're facing, but when you can tell, it's clear that they are now facing in the correct direction. So, good thinking. Right, let's add an enemy. So the first thing we do when we add like a new entity, object, whatever, is make a sprite for it. I think we'll just call it S-enemy for now. We'll probably have more than one different type eventually, but we can change that as we go. And so we create a new sprite, we go to new. Let's make the canvas for this one 64 by 64 instead of 32 by 32, because I think the enemy should be bigger than us. Why? Because players question the morality of their actions less if they feel outmatched. In other words, if you're fighting things that look smaller and punier than you, then you feel kind of bad about it if you just mow them all down. Whereas if they're bigger than you, you think, well, I had to kill them, they were bigger than me. That won't really matter in our game. Now, our player is like black, our bullets are orange. Let's make the first enemy like greenish, I guess, doesn't really matter. And let's make them kind of like gross and blobby. Let's make them lumpy space enemies. And do we even want any kind of shading at all? Let's try it because it will be funny how bad it is. Important to make sure your mistakes are funny. Oh god, I'm really not an artist. Okay, there we go. Perfect. Great enemy. Let's give it eyes, because then at least, because there's a practical reason for that too. We want to be able to see which direction it's facing. So, what am I doing there? There we go. And little black pupils. Or maybe red pupils, because they're evil, then you'll question your morality even less. Oh my god, that looks so bad. I mentioned this before, but this is not an art tutorial. So we've made our sprite, and we just click center here to make sure it's in the center. And so that is just an image. What we need to do now is create an object. So we right click on object, and we'll type, oh, enemy. Oh my god, what on earth just happened there? We must have caps lock now. Okay, oh, enemy. And unlike last time, we're going to remember to set the actual sprite to what it really is. And let's be safe rather than sorry. Wait, what's the phrase I'm looking for? And just test that it even exists. So open up a room, we go to the Objects tab. Down here, this is where you choose what to place. Last time, the only object we've placed before is the player, and that was the default thing to place. This time, for some reason, the bullet is the default thing to place. We don't want to place a bullet, so you have to click here and select enemy. So that little box is choosing what clicking the left mouse button will do. In fact, it says that right there. And now we're just going to place one enemy. And click the green tick, and click the green play button. And you're going to double check this is recording. Yes. Okay. There's our hideous, hideous enemy. So you don't feel at all bad about shooting it, even when it doesn't have any, well, especially when it has no effect on the enemy. So, let's do AI. Why not? This enemy, right now, he just sits there and does nothing. So we're opening up its properties by double clicking. I would say, what event do we need? We're certainly going to need a step event. We're going to want to do something every now and then. And I think what we want to do is kind of like just move around the screen randomly. In fact, no. We do want to move around the screen randomly, but I don't think we could have it like sort of intelligently change direction at certain times and have it be on like some kind of timer. But I think since our game is very simple and our room's very small, it could just move in a random direction. Then when it hits the edge of the room, turn around and come back and just sort of bounce off it almost. And so to do that, what do we need to do? We need to pick a random direction, and then yeah, I think we'll do a create event because we didn't do one before, and it's important to. It's an important thing in general. Our code has been so simple so far that we don't need, like, everything can run on a step event. The step event's the one that triggers 30 times a second, so everything's kind of constant. But the create event only triggers once, and it's only when the creature is created. If we created another one, that creature would run its own create event when we create it. And like when we create a bullet, for example, every time you fire a bullet, each bullet is running its create event once when it spawns, and then it doesn't run it again. So our enemy, we've added the create event, and then we go to control, and we find the code action, and we drag that in, so that it gives us a little window of code to write. And in here we're going to say, so we already learned about speed and direction variables, so now that, because we're writing this code on the enemy, we don't need a name for the enemy or anything. We can just write speed equals, and what should the monster speed be? Our speed is 10, the bullet speed is 20. They should be slower than us by quite a lot. 5? Let's go for 3, let's make them really slow first. Speed equals 3, and direction, we want it to be random. If we said like direction 45 or something, then every enemy we ever spawned would always head up and to the left, up and to the right. But we want each one to go in a different direction. We don't really care what direction it is as long as it's different, so we're going to pick a random number. And I mentioned this very briefly in the first episode, but the word for that is just random. And for angles, they go between 0 and 360 degrees, so we're going to say random 360. I think I'm right in saying that it will never actually pick 360 itself, like it will be between 0 and 359.999, whatever. We don't care too much. If it did pick 360, I think the game would figure out what you mean by that. So that just says move at speed 3 in a random direction, but that's in the create event, so that'll only happen once. They'll just spawn, they'll move in a random direction, and then they'll keep moving in that direction, but nothing else will ever change or happen. Like, they'll just move off screen probably. So let's see which direction is going to go. It's going to go up and to the right, and he slides off screen and he's gone forever. That's more or less what we thought would happen. One thing, okay, so that is this is the create event is just for setting the initial conditions. So speed we probably won't change once the thing's been created. Direction we will want to change sometimes, and obviously one of the things we noticed just then is he looks to the right even when he's moving in a different direction. So we want to change that, but there's no point doing that create event because we want that to always be true, no matter, even when his direction changes, we want it to keep looking in the direction. So if we put the code here, it would only run once, and then if it changed direction later, it wouldn't run again. So since we're going to have to write it in the step event, we only write it in the step event, because who cares if it's correct for the one frame where the thing is created. So we're going to add event and step, and then drag the code action in there. And so let's sort that facing thing first, and we'll do the heading again. Facing image angle, that's the way we appear to be facing, equals direction. Direction is the way we really are going. And I think are we advanced enough that we don't need to test that? I'm pretty confident that's going to work. Now what we want to do is say, let's call it bouncing or something. Again, these green comments are purely aesthetic, they're purely for reference, they don't affect the code in any way, they're just to remind me what the code is doing. What we want is that when you go off the edge of the screen, you bounce. Now we could do that with things like figuring out what angle we're coming in at and calculating the new angle for our direction, like relative to the boundary that we've hit. It's actually not that complicated, you don't have to do it the hard way. What we can do is, what we want to happen is if you hit the top of the screen, we want your horizontal velocity to be exactly the same. We don't want you to suddenly stop and go down or go backwards. We want to carry on going horizontally that way, but we want you, hope this is on the screen, we want your vertical velocity to invert, basically. We want you to go back down. So a thing bouncing off the top looks like that. What's happening there is the horizontal velocity is staying the same, vertical velocity is reversing. So we have special words for that. We have h speed and v speed, horizontal speed and vertical speed. So first thing we need to write, we're using the if statement again, and we want to talk about our vertical coordinate, y, and we want to say if it goes off the top of the screen, and as I said before, low values of y are at the top and high values of y are at the bottom, which is a bit weird because it's not how a graph would work, but the best way to think about it is like a piece of paper. If you're writing on a piece of paper, you start on the top left, and the top left of the screen is 0, 0, and as you go right, x increases, as you go down, y increases. So the top of the screen is y equals 0, and if we're at 0 we don't care, that's fine, but if we go less than 0, that would be bad. So that is shift and comma on your keyboard, and that's the less than symbol. If y is less than 0, that means y has gone negative, that means we're going off the edge of the screen. Then, we open braces, that's shift and square brackets, what we want to happen is vertical speed, v speed, equals v speed. Now we want it to go in the other direction. So if we're heading off the top of the screen, our v speed is negative because we are going towards 0 and we're about to go past it. So our y is decreasing, which means our v speed is negative. Our v speed might be like -1 or something, and we want it to be +1. So we multiply it by -1. So equally, if we're going off the bottom of the screen and our v speed was 1, like our vertical speed is positive, then to invert that you'd multiply it by -1 and you'd get -1. If it was 10, you multiply it by -1, you get -10. So that is how you make something go in the other direction. You multiply it by -1. So that's the top of the screen. And in actual fact, so the other thing we want to check is, did we go off the bottom of the screen? Let's just deal with verticals first. And if we did y, the way you do that, obviously we're looking at y again. This time we're looking at, did it go greater than something? And the number we want is the height of the room. And guess what? That's called room height. And then we would open these curly braces, and what we would write is v speed equals v speed times -1. I just said that, right? If we had positive velocity, you would still multiply it by -1 to invert it. So you might notice that's exactly what we said last time. So actually, to make something bounce off a boundary, we don't need to know whether it's going up or down. It's the same code. We're not saying like, oh, if you go off the top, then make our velocity positive. We're saying whatever our velocity is, just invert it. So we don't need to know whether it's positive or negative. We're going to make it the other one. So our code is nice and generic. That works for anything. So instead of having these two separate if statements, we can combine them. This isn't really important. You don't have to do this, but let's take our y greater than room height, And what we want to say is if y is less than 0 or it's greater than the height of the room, then we invert. And you can do that literally with the word or. If y is less than 0 or y is greater than room height, then this happens. We can delete this whole other one, and that's our whole code for vertical bouncing, which is rather neat. The word or is rather nice and common language, and that's just how you'd say it. The only thing to bear in mind is if you wanted to say something like, let's do this in new one. If you want to say if y equals 1 or y equals 2, you just have to remember that's correct, but you couldn't say if y equals 1 or 2, because GameMaker doesn't know that you're still talking about y at this point. Like, the thing before the or and the thing after the or have to be completely self-contained full statements, so you'd have to say y equals 2. What happens if you just check y equals 1 or 2 is trying to check whether 2 is true, whether the number 2 is true, and that's it will probably do it, because it's GameMaker. Instead of crashing or producing an error, it will say, yeah, sure, 2 is true, whatever. It just carries on. That's kind of how it works. Anyway, that is our vertical bouncing code. Shall we test it? Let's not test it, because our guy might just go off the horizontal axis and then we won't learn anything. So, and it's really easy to see how to convert that to horizontal, right? Copy and paste the whole thing, and now everywhere that we said y, we want to say x. And instead of room height, we care about room width, because x is our horizontal thing. And again, as we're writing this, we don't even need to know which side of the room 0 is and which side is room width. And v speed, we want h speed instead, horizontal speed. So now we say if our x-coordinate is less than 0 or it's greater than the width of the room, then our horizontal speed should go in the other direction. So these two things quite neatly will produce a kind of something that looks like realistic bouncing. I mean, our thing isn't physically bouncing, it's really just an enemy that's decided to go in a different direction, but that's kind of how we want him to move anyway. So, he's going off, he's going off. Is he going to come back down? Yes! And he looks in the right direction as well. And he's going to bounce off that side? Yes, brilliant. So now he's roaming around. God, we've made, I don't know, like, the shittiness of that sprite is just deeply troubling to me. It's making me really sad. But we can circle him. He almost looks like a boss, doesn't he? We could be circling him and like spraying bullets into him to try and take him out. Now, what do we want to happen when a bullet hits him? That's our next thing. So, we've got the enemy moving around. Now we want to talk about what happens when a bullet hits the enemy. We could have him just instantly be destroyed in one hit. That's the easiest thing to code. But he looks big and meaty. He should probably take a few hits, right? So there's a bunch of things I would like to, since we're just making kind of a shooter, I would like to do just a few interesting different ways of handling damage. The most boring way would be to have a health bar pop up. I don't like that solution because it adds abstract information that isn't represented visually in the game except by an interface element. And interface elements are kind of a cheap hack to represent information that's hidden when it shouldn't be. Like, hit points just aren't really the way things work. I don't find them convincing, I don't find them satisfying to interact with. So we're not going to do a health bar. But we should have him take more than one bullet, I think, because he's nice and big. So, I'm just thinking out loud, really. We've got that bouncing code here. Let's call this damage, the next section, and this will handle what happens when a bullet hits us. So the first thing, and this is going to be a really useful thing for everything ever, that is the vaguest sentence I've ever said, is how do we check whether a bullet's hit us? We type if place, let me think. No, okay. The way we're actually going to do it is we don't just want to know whether a bullet has hit us, we want to know which bullet hit us. Because when the bullet hits us, we probably want the bullet to be destroyed. So we need the name of it. So, as before, we had, do you remember when we created the bullet, we had my bullet equals instance create bullet. This time we want to know which one hit us. So we're going to say, should we say my bullet? Does that make sense? Let's actually write incoming bullet. It's good to be as specific as possible. Incoming bullet equals instance place. That is a function that says if is an object of a certain kind hitting me? And if it is, tell me which one is hitting me. So, is it hitting me, and if so, tell them to stop. Instance base, open brackets. The things it wants from us, it pops up down the bottom. It wants an X position, a Y position, and an object type. The X position and the Y position that it wants from us doesn't want anything special. It actually just wants to know this function can not just check collision in your current position, it can check collision in a new position. So we could say something like, oh, if I move to this spot, will I be hitting a wall, for example? And for that, you type in the location you want to check, and then a wall type, and it will tell you. In our case, we just want to check ourselves. We're not doing anything fancy. We just want to say, is a bullet colliding with us here, right now? So we just say X and Y, because that's our current position. And then the object type is OBullet. Should remember that when we close the brackets. Now, we have said, like I said, that function checks whether there is a bullet hitting us, and if there is, it will return its name. So we have given a name to that. We're going to store that name as incoming bullet, but we don't yet know if that's happened. There are two possibilities: either a bullet's hitting us or if it isn't. If a bullet's hitting us, incoming bullet will store its name. If there isn't a bullet hitting us, we've just written a weird thing, where incoming bullet equals this thing that doesn't exist. So before we do anything with incoming bullet, we need to check that it exists. Does it exist? So that line's doing two things at once. It's checking whether that's true, and if it is, it's remembering the important piece of information we want. So now we want to check, did we actually get shot? And for that, we just do if instance exists incoming bullet. So hopefully that makes sense. We're saying if we got hit, store the name of the bullet that hit us. And then we're saying, if the bullet that hit us exists, if there even is one, then we'll do the damage code. And for now, we will just say, we'll just destroy ourselves. We will destroy, let's just say instance destroy, and that's a function, so it needs the brackets, but in this case we don't need to supply it with any information. It knows that when you say instance destroy, you're always destroying the object that's saying that. It's like a suicide word. So let's just test that, because that was a lot of explanation. So we're not using that name particularly for anything that fancy yet. We're just seeing if a bullet hit us, and if it did, we destroy ourselves. There it is. He's gone. So there's only one enemy, and as soon as you hit him, he destroys himself. But the bullet itself didn't get destroyed, and that was why we did this. We wanted to do it this way so that we would be able to destroy the bullet. And should we do that next? Actually, let's not do that next, because right now we're firing so many bullets it doesn't really matter. Like when I shot that guy just then, you barely noticed that the bullet went through him, right? I was firing so many other bullets that all the other bullets went through him anyway. So let's instead do damage. Let's see, what do we want to do for representing how much damage the creature has taken. And I think instead of destroying him instantaneously, when a bullet hits him, we are going to... It's quite big, so I think we should shrink him. So let's do image. We want to, like, when you hit him, we want the image to shrink. And I wonder, let me actually check. Image scale. No, it's not a thing. Okay, so if I type image underscore, it'll pop up with a bunch of things. And the way I normally do this is to change the X scale and the Y scale. I was just briefly wondering if there was like a universal scale thing. There isn't. So image X scale equals, we want to reduce the scale of the image. So we're going to say image X scale equals image X scale minus 0.2. 0.2 is a fifth of 1. 1 is the normal value. If we did something like image X scale times 0.8, that would make it a fraction of its former size, and that would mean it gets smaller and smaller and smaller, but it would never disappear. I think we actually do want it to disappear, so we'll subtract minus 0.2 instead. If we subtracted 1, it would instantaneously disappear. And we want to do the same thing to image Y scale, but rather than write out the maths again, I think we'll just we always want image x scale and image y scale to be the same. We always want nothing to be, we don't want it to stretch or distort in any dimension. So we'll just always say image y scale equals image x scale. So no matter what happens, they will both be the same. We can test this. There's a problem with this, but I'm going to show you rather than tell you. And it's one we can easily solve. So what we've told, if we think about what we told the game, we told the game when if the bullet is hitting us, shrink our size by 0.2, a fifth. And what happened was, he got shrunk loads. He's tiny now, and then he's gone. I actually thought he would disappear in one bullet, but he didn't, because our bullet's travelling quite fast. So why did it have way more effect than we thought it would? We should have just shaved a fifth of his size. The reason is, we don't destroy the bullet yet. We've remembered the name of the bullet, but we don't do anything to it. So all we're doing is when the bullet hits us, we subtract a bit of our size, and then next frame, running this 30 times a second, the next 30th of a second, we check, is the bullet hitting us? And yeah, it still is. We didn't destroy it, so it's still hitting us. I guess we lost a bit of size, so it's possible that in that frame it would kind of get out of our radius, and then it would hit us again. But either way, that's not what we want, is it? We don't want the bullet to repeatedly hit you as it goes through. We want it to hit you once and then stop affecting you. So let's actually destroy the bullet. So now, remember previously we said instance destroy to destroy ourselves. Now we want to destroy the bullet, and we need to basically run a bit of code on the bullet. We need to run the instance destroy word on the bullet. The bullet needs to run that, not us. So the way you do that is to say with incoming bullet, and then anything we put between these curly braces will run on the bullet instead of us. So that suicide word, instance destroy, it's a bit of a weird function because instead of telling it what you want to destroy, it always assumes you want to destroy yourself. It's like, oh, you want to kill something? I'll kill you. So we have to say with incoming bullet, and then we're saying, like, I don't want to say instance destroy. He wants to say instance destroy. Destroy him. So that will destroy the bullet and it won't destroy us. And that means the bullet won't trigger the same thing again. If two bullets hit us, then of course it will trigger twice, but it won't trigger multiple times with the same bullet because the bullet is destroyed in the process. Okay, what I did there was I fired like 100 bullets at the things, so that making it impossible to test. Something we should add soon is a restart button, because actually rebooting the program is a really terrible way of resetting it. So let's wait for him to bounce back, and then let's try firing one bullet. Okay, that was 2 bullets, but that's much better, right? 2 bullets hit him, he shrunk twice. That's what we wanted. And it's got a little difficulty curve to it, because the more you hit him, the smaller he gets, and so the harder he gets to hit. But that's kind of fun, I quite like that. So there's one thing we need to change here. Right now we shrink the guy, we never destroy him. So when he disappears then, it's not because he's actually been destroyed, it's because he's just scale 0 and probably scale like -6 at some point. Because we keep reducing it, we never check whether we've already reduced it to 0, and we never destroy him. So I think we want to destroy ourselves if that's got too low. The way that it makes sense to me to do it is actually to destroy the bullet first. So the first thing, when the bullet hits us, the first thing that happens is we destroy the bullet, then we shrink ourselves, then we check to see, did we shrink ourselves to oblivion, and if so, destroy us. So here's the bit where we check. Let's even put this as a comment. I'm going to do this with 2 slashes, because that's just the way I write these comments. Destroy the bullet. Shrink ourselves. God, I'm terrible at typing. And then the next thing we want to do is if, or let's say, destroy us if we've shrunk ourselves to oblivion. That's a comment I've never written before. If image x scale is less than 0, let's say less than or equal to 0, because if we just hit 0, we want to destroy ourselves. So when you do a less than or greater than thing, you can put an equals after it to include the boundary as well. Then open the braces, and we'll say instance destroy, and close the braces. So because we're saying that about ourselves, we will be destroyed. we're only checking image X scale because we know they're going to be the same. Like we literally said right here that they are the same thing. So we don't need to check Y scale separately. And we're saying if it's less than or equal to 0, destroy ourselves. We could actually just say equal to 0 because we know that this thing is, we're subtracting 0.2 every time, and we know there's only 5 of those in one. Like after 5 hits we will hit exactly 0. But that's a bad idea because, sorry, less than. We might change that one day. We might decide that's too much damage and we reduce it to 0.15, and that doesn't divide equally into 1, and so then we would only be destroying ourselves at 0, and we would actually be stopping before 0 and then going past 0, and would never hit 0 itself. So you always kind of want to say, like, the issue here is not whether we hit 0 exactly, it's like, did we get as low as 0? Did we get 0 or below? It's good to kind of just keep clear in your head what the meaning of the code you're writing is, so that you don't allow for weird edge cases that could mess it up. So this is going to have basically exactly the same effect. But let's see. Oops. Yeah, one just grazed in there. I think hopefully the collision is updating. Yeah, that's quite cool. Okay, now this is probably running a bit long, but I'd like to do just one other quick thing to make this more of a game, because right now we destroy an enemy and then the enemy's gone and then our game is over. It's a really short, sad game. To make this like an endless shooter, we can do something really simple, which is just when an enemy is destroyed, create a new enemy. We can even create 2 new enemies, but then it'll get out of hand really quickly. We might look into that in a future episode, actually, like how to balance enemy spawning. But for now, let's just say when one enemy is destroyed, we create a new one. So we know when one enemy is destroyed, there's only one way it can happen right now, and it's here. So before we destroy ourselves, let's say instance create. We could just do XY enemy. So we're saying create a new enemy at R position. But our position is a bad one because a bullet just hit it. And although we destroyed that bullet, there might be another one incoming, and you don't want to immediately hit the next enemy, and it would look like the enemy was just re-inflating. It would be weird. So what we actually want is a random position in the room. And you remember from earlier we had room height and room width. Those are the largest numbers that fit within the room. So we want a number between 0 and that. So we already know that, right? We already know we can do random room width and then random room height. And what that says is pick a random number between 0 and the width of the room, and that's our x coordinate. Pick a random number between 0 and the height of the room, and that's our y coordinate, and create an enemy there. So that is a random place in the room. And then destroy us. So let's quickly check that that's working. And then we'll probably leave it there. So destroy this enemy mercilessly. A new one appeared. Actually, it did appear in our line of fire just by coincidence. But then new one appears down there. And now we have an endless shooter. We can fire so many bullets so fast that it's kind of a problem. But that's already feeling much more like a game, right? It's still a bad game, but it's kind of, now there's a way that it can perpetuate, and we've made a kind of endless shooter. And actually it's more fun than I thought. Like, it's not fun, but it's the fact that they keep popping up is, I don't know, it sort of adds something to it. I'm not sure what yet. But, yeah, it's not as awful as I thought. So that's something we could actually think about. Like, maybe, I've seen some games where, like, enemies do spawn in a random position, but they give you, like, a warning before they spawn in, so there'd be, like, a marker on the ground, so you know you don't want to stand next to it. Obviously, right now we can't be killed by enemies, and we should probably add that next. And in fact, so I'm going to leave this one there, but that is now our first week. We've done 3 episodes of it's probably only like an hour and 15 minutes or something of actual total time. And I won't do another one until next week. And what I'd like to do is let you play around with these ingredients. So I've shown you how to create things, how to destroy things, how to place things randomly, how to shoot things, how to grow things, how to shrink things. And with those ingredients and any other that you might like to come up with, I'd like to task you to come up with another enemy type, I think, and decide how it should react to being shot. You could also make this or the new enemy type affect you in some way. Maybe it just destroys you when it touches you. That would be you already know how to do that from what I've just told you. So that would be a good exercise to check that you've understood it. Or you could have something more interesting happen when it touches you. Maybe there is some concept of damage. I'm not particularly interested in, like I say, health bars or hit points or numbers. Anything that has to be represented by an interface element, I'm kind of less excited about. But yeah, what I'd love to see happen is for those of you who are following along with it to kind of invent things yourself and come up with creative ideas for what to do. And then you can either keep them to yourself and make your own game out of it, or if you want to send them in, if it's just like, so for me this is a total throwaway project. I'm never going to do anything with this. I'm releasing the source code for free every time I put up an episode for this. I release the final game for free. I will never ever sell it. And if that's the way you feel about your version of this too, your own tutorial project, if you know already, like, this is not the game I'm going to make, this is just a test project, I don't care about any of the things I'm doing, then you could send in what you've done to me, and you could pick like my favourite one of those things and incorporate it into the game maybe. One thing that would be great to get would be any art you might have done. I'm like maybe struggling on that front. Not an artist, and I'm not going to teach you how to be an artist, but if you already are an artist, or if you've already just done something worthwhile, hey, where did I go? Oh, here I am. That would be great. But again, I want to emphasize, like, if you've done something of value, don't give it to me. Keep it to yourself. Make something good out of it, and then one day you can sell it. You can do that anyway, but if what you've done you just don't really value particularly, and you want to contribute to this thing, you can send it to me. The important thing is, when you send it in, I'll put this in the description, the details of where you need to send it and what you need to say, but it will involve you saying in the email, I'm releasing this under a Creative Commons, let's get the name right, I looked it up earlier, Creative Commons Attribution Non-Commercial International License. Basically you'll just copy and paste this word, this bit, and link to this page. Again, I'll put that in the description. And this is a license that says anyone can share and redistribute what you've given, what you sent. Anyone can adapt it and do anything they like with it. And the only condition is that, I should say somewhere here, that no one can sell it. So I can't sell it. No one who takes your work can use it in something and then sell that thing. You still can if you want to. You can. You could go on to like sell it in some capacity or use it in your own thing that you sell because it's yours. But you won't be able to revoke the license that you've made here. So if you don't do it unless you're totally sure that you don't want the thing that you've made, or you're totally happy with it being out there already. Like a good example is just the code I've written for this is, it's code. I might use it in something one day. I don't know, maybe I'll write some code here that's a bit more elegant than something that's in heat signature, and I want to use it in a heat signature, and I'm going to sell that. But that's code that I've written, and it's kind of valueless to me. I don't care if everyone in the world has that. Even if I do use it in something commercial, it's so trivial and so simple that it's no skin off my back if loads of other people are using it too. So if you feel that way about this stuff, then send it in. Sorry to whittle on about this, but I'm really, really don't want this to be a thing where like people send me things they're really proud of and then they're kind of out there. I don't know, it seems like it has the potential to go bad, but I like the idea that this could be a thing that we kind of make together and that different parts could come from different people. But yeah, I want to stress I'm totally happy to make this whole thing myself, and that it'll just be hideous. That's the only drawback of that. So yeah, I think that's everything. Yeah, like I say, the next episode won't be until next week. We'll probably do player death and incorporate any cool things that have been sent. And thanks so much for following along. Oh yeah, the first episode now has about 20,000 views on YouTube, which is way beyond what I was expecting. And the second episode has about 3,000. So if you're watching this, about 1 in 7 people make it from the first episode to the second episode. So if you're watching a third episode, you're in the elite cadre of people who actually stuck with this. So well done for that.